Ladies and gentlemen, dear participants of the IBIMA conference, my name is Barbara OCICKA. On behalf of myself and the co-author, Professor Jolanta TUREK, I would like to present main findings and conclusions based on our paper titled Collaborative Risk Management in Food Biopackaging Supply Chains. The agenda of the presentation is as follows. I will start with presenting the research scope and methodology. The second part of the speech will cover the purpose of our article. Then I will consider main drivers of bioplastic-related risk. Next, I will introduce multi-stakeholder solutions within collaborative supply chain risk management dedicated to the development of food biopackaging market. I will close the presentation with the main conclusion. The presented topic is a part of the 3-year project New Frontiers in Social Innovation Research, Social Innovation Management for Bioplastics. Symbio is a joint initiative of researchers representing Coventry University, Federal University of San Carlos, Simon Fraser University, SGH Warsaw School of Economics, and University of Łódź. The project is implemented under the Transatlantic Platform Program and in Poland is financed by the National Center for Research and Development. The main purpose of the project is to develop social innovations to meet the challenges of using bioplastics packaging in the food supply chains based on the circular economy principles. However, bioplastics are a large family of materials with different properties and applications. They can be fossil and bio-based on the one hand, and biodegradable or non-biodegradable on the other hand. We focus our research studies on the biopackaging segment that refers to packaging made of bio-based materials which are fit for biodegradation in line with the circular economy principles. We are especially interested in the sector of certified compostable packaging. The Symbio project is a multi-stakeholder research platform. We conduct our study within an extensive network of internal and external stakeholders of food biopackaging supply chains. Internal stakeholders include suppliers of raw materials and bioplastics, packaging manufacturers, packaging distributors, business customers like food manufacturers and retailers, consumers, as well as waste management entities. External stakeholders include organizations for standards development and certification, research and development institutions, public administration institutions, and non-governmental entities. The Symbio project includes 4 stages of the research procedure. The first stage, defining key challenges, aimed at the diagnosis of activators, supporting factors, and barriers to the development of the food biopackaging market. The second stage, understanding problems, paid attention to the identification and analysis of the causes of problems and barriers to the food biopackaging supply chain management in line with the circular economy principles. The third stage, exploring solutions, aimed to the identification, evaluation, and preliminary designing of potential solutions to problems, barriers, and their causes in the biopackaging market. The fourth stage, prototyping solutions, is mainly concentrated on rapid prototyping of the chosen social innovations. Based on the in-depth qualitative research study within the Symbio project, the purpose of our IBIMA article is to identify the main drivers and types of bioplastic-related risk and to explore the multi-stakeholder collaboration for managing this risk in food biopackaging supply chains. In the light of the literature review, we contribute and extend the knowledge regarding the implementation of supply chain collaborative risk management, adopting the multi-stakeholder perspective and presenting its development and significance based on the study of food biopackaging supply chains. It is also worth underlining that there is significantly less knowledge available and less attention paid to bioplastic-related risk identification and management than to plastic-related challenges. Generally, four main problems for the development of the food biopackaging market have been identified that can be considered as major drivers of bioplastic-related risk in food biopackaging supply chains. The first problem is a low share of bio, including compostable packaging, in the food packaging market. Its scope covers such barriers as high prices and limited properties of bio compared to plastic packaging. Additionally, there are no actions to compensate for the competitiveness of bio in relation to plastic packaging. Meanwhile, a generally low awareness and willingness of consumers to buy food products in bio, including compostable packaging, have been identified. Next, the problem third was diagnosed, which is an insufficient social and environmental responsibility of enterprises in food packaging supply chains, hindering strategies and actions to the benefit of the circular economy. Another pressing problem for closing the life cycle of biopackaging is a low level of development of packaging waste management in individual waste streams, including separately compostable packaging waste. The four just mentioned problems determine a plethora of different types of bioplastic-related risks, among others: risk of raw materials availability, risk of rising raw materials prices, risk of high logistics costs, risk of high manufacturing costs, risk of limited possibilities to achieve economies of scale, risk of high certification costs, risk of losing synergy effects in biopolymers purchasing and biopackaging R&D and production, operational risk in composting plants, as well as risk of low market demand, risk of non-recognition of biopackaging by consumers, risk of not following the circular economy principles by consumers, risk of mismatch of technical and technological solutions with consumer needs, risk of reputation damage due to greenwashing practices, risk due to lack of consumers' readiness to buy more expensive biopacked food products, risk of failure to meet the requirements of separate biowaste collection. Although the food biopackaging market is at an early stage of its development, multiple stakeholders can contribute together to diverse initiatives within early supplier involvement and supplier development like new biopolymers, biopackaging and technologies development, or the definition of market standards. The cooperation of stakeholders is desirable both on the demand side and on the supply side, as well as with supporting stakeholders, such as, for example, institutions financing grants for the development of new bioplastics, institutions supporting the introduction of new materials into the market, and certifying institutions. As an example, biopackaging needs to meet strict requirements to be classified as compostable. Each element of the biopackaging must be certified as compostable. Developing new biopackaging entails a series of tests to verify its properties. The close cooperation between various links in the food supply chains would foster the product development and decrease operational risk. On the other hand, the use of biopackaging for food products usually requires a change in the technological process itself. It results from the need to adapt machinery and equipment parameters to the physical properties and structure of biopackaging differing from conventional plastics. The costs of upgrading the machinery park are high. This technological transition is another field for multi-stakeholder cooperation through early supplier involvement and supplier development. Finally, to address the problem of information house and reduction the bioplastic-related risk of greenwashing, it is necessary to set standards in biopackaging production. The certification is a field of potential collaboration between stakeholders, including suppliers of raw materials, manufacturers of biopolymers, buyers of biopackaging, and certification bodies. To support bioplastic-related risk management, it is worth considering the creation of a multi-sided B2B technology platform. The platform having a wide range of participants may constitute a multi-stakeholder bridge. Such a platform enables the integration of processes and streamlining the flows within the supply chain management, industrial collaborations and co-opetition, generation of particular synergies, transformation of B2B relationships in different supply chain contexts. The relationships among platform participants result from mutual understanding and trust. The cooperation is effective when there is a common goal for all participants. It should be based on the framework of common business and contract rules, governance, including mechanisms and policies, terms and conditions, principles, decision rights, and goal achievement control. The cooperation leads to supply chain integration within the key business processes, such as demand management, supply management, sales and operations management, as well as product portfolio management. Respondents confirmed that MSP provides the biopackaging market with better coordination and streamlining of information, knowledge, document, financial, as well as materials and product flows. Introducing the MSPs results in achieving several synergy effects, such as economies of scale and scope, lower transaction costs, complementary innovations, network effects, circularity, and risk management. Our main conclusion is building multi-stakeholder bridges is essential to manage bioplastic-related risk in food packaging supply chains. On behalf of myself and the co-author, Professor Jolanta TUREK, I thank you very much for your attention. We invite you to follow the results of our research at the website. For further information, please contact our project team in Poland. Thank you.